Okay, I'm back, and we are going to try to do page 3 of worksheet 1. On page 3 of worksheet 1, I'm only going to do examples like 7 and 9 because problem 8 is similar to, it's one of those absolute values divided by itself kind of things, similar to number 5 from yesterday. So if you're confused, go back and review that video. Notice another three-parter. This is a parabolic ray left, a parabolic ray right, and this is simply an ordered pair. So when I'm looking at the left, I have a parabolic ray left. I insert the 1 and I get 0. Now the thing about a parabola is that you always want to find its vertex. And its vertex in this particular case is going to be 0, -1. Notice 0 is less than 1. And this parabola opens up, so I want more than half of this parabola. And so it's going to take on a shape similar to this. My endpoint is not closed. I've already put in the magic dividing line. So I'm going to plot my ordered pair 1, 0 as an open circle. The vertex is 0, -1. Using symmetry, I can put in my third point. That's all I need. But since A is 1, you can say, oh, just go right 2, and you can go 1, 2, 3, 4 up for those of you that want to put in an extra point to make it look prettier. Let me try to get that better. So there's a little better. And then I can do my parabola like that. I can put an arrow on. I come here from the left side. The function f of x is x squared minus 1. 1 minus 1 is 0. Now for the ordered pair, just a single point because it's an equal to 1, 2. So here is the ordered pair 1, 2. And that's the ordered pair, the function value 1, 2. Now again, I have a parabola from the right side, and this is a parabolic ray right. Its endpoint is also 1, 0, and it's open. But its vertex is 0, 1, and 0, 1 is not in the domain. So I don't want the whole parabola down. I don't want half the parabola down. I'm going to get less than half. And note, it's not going to be an oblique line, so don't make it look straight. It's going to be curvy, and it's going to be open. And so this is the same point. And at this point, since it's not going to use symmetry to graph it, I would probably say, well, what happens when I insert 2? Well, 1 minus 4 is -3. So that gives me a point. And maybe we could go over to 3, and 1 minus 9 is -8. And down here would be that point. And I can see that, it's still curvy. It's still taking a curvy look to it. So do not try to make it like a straight line like we had on page 2. And so I come over here and I put in the actual name of f of x when I'm greater than 1. 1 minus 1 is 0. While they're equal, it's 0. But notice these two are not equal. And since these two are not equal, we have a hole or a point discontinuity. And how do we know that it's a point discontinuity? if I came to my open circle and I filled it in, which is illegal, but I filled it in, wouldn't it be nice and continuous? That tells me visually that it's a hole versus a jump. Because when you have a jump, you cannot fill in that hole. And so, but it is still a point missing. It popped out up here. So again, like I stated, number 8 is the absolute value of a quantity divided by the quantity. So if you're confused, go back and look at number 5. Jumping on to number 9, I'm going to mix a parabola with an oblique line. And so this is the left side of my parabola. So I have a parabolic ray left. When I insert 2, I end up with 4 minus 2 is 2. It's closed because this one states that it's equal. I find the vertex 0, negative 2. Notice 0 is less, so I want more than half, but this time it's closed. And that's still the arrow up. And I'm ready to do my graph. So I come in, I plot 2, 2, closed. I know the vertex is 0, negative 2. I can use symmetry. I only need those points, but most of you like to have the 1, 1 points in. So feel free to put that in, but that stops at the line, and this keeps going up. And so we have our parabolic ray. And by the way, since this is the equal to, my function value is also 2. Now I'm ready to do the left side, which is an oblique line. So that's an oblique ray right. And when I put 2 in, 8 minus 6 is 2. Oh, wow, notice they're equal to each other. And when they're equal to each other, we know that there's no other points anywhere else. This tells me that I'm going to be continuous momentarily. Oh, I'm sorry, I jumped ahead of myself. I forgot to do the limit down here. And we get 2. Sorry about that. And so now I have 2, 2, but this is an oblique ray with negative slope. I want the right side. It says it's an open circle, but I see it's already filled in. My slope, negative 3 over 1. I like it because I'm moving right. If I wanted to move left, I would make the numerator positive and the denominator negative. So I'm going to go 1, 2, 3 down, right 1, 1, 2, 3 down, right 1, 1, 2, 3 down, right 1. I just like to, it helps me draw and make the graph look prettier. To put in arrows or not put in arrows, that's your decision. This is 8 minus 3x. I insert 8 minus 6 is 2. They're equal. It's 2. Notice these are equal. And so I can conclude continuous. Nice, pretty graph. I don't have to pick up my pen, pencil, chalk, marker, finger. Nice and continuous.